6 months ago, your model hit 92% accuracy. You deployed it, moved on, and never looked back.
Today it's making wrong predictions, and nobody noticed. Hi, I am Mahaz, an AI engineer.
Last episode, we took a trained model and served it as a live API. Today, why models quietly degrade after deployment and how to catch it.
Episode 32, Model Monitoring and Data Drift. A model is a snapshot of a pattern that existed in your training data. The real world is not a snapshot. It keeps changing.
Users behave differently in January than in July. Products get discontinued. Regulations change. Economic conditions shift. The model's internal rules stay frozen while the world around them drifts.
Accuracy drops, not because the code broke, but because the world changed.
This is model decay, silent, gradual, and almost always unnoticed without monitoring.
Data drift means the distribution of your input features has changed.
At training time, the average customer age was 32. 6 months later, the product attracted a younger demographic, average age 24.
Your model was never shown that distribution. It generalizes badly to it.
Data drift is about the the features, shifting over time. The relationship between features and labels hasn't changed. The inputs just look different.
Detecting data drift early lets you retrain before accuracy visibly suffers. Concept drift is different and harder. The inputs look the same, but the correct answer has changed.
A fraud detection model trained before a new scam technique appeared. The transactions look identical to legitimate ones, but they're now fraudulent.
The relationship between X and Y has changed. The model has no idea.
Concept drift cannot be detected just by watching input distributions. You need ground truth labels from the real world, which often arrive late.
That delay is why concept drift is the harder, more dangerous problem.
Population Stability Index, PSI, is the standard metric for data drift. It compares a reference distribution, usually your training data, to a current distribution. PSI below 0.1, stable, no action needed. PSI between 0.1 and 0.2, mild shift. Monitor closely.
PSI above 0.2, significant drift. Investigate and probably retrain.
PSI works on bucket feature values. You bin both distributions and compare bin proportions.
One number, one threshold, immediate verdict. That's why it's been the industry default for decades.
Even without ground truth labels, you can monitor the model's output distribution.
If the model used to predict class 140% of the time, and now it's 80%, something changed.
Track the mean predicted probability over rolling windows, daily, weekly. A sudden jump or gradual trend is an early warning sign. Prediction distribution monitoring catches both data drift and concept drift symptoms.
It's the cheapest monitor you can add. No labels, just log your model's outputs.
2 statistical tests cover most drift detection scenarios. The Kolmogorov-Smirnov test compares 2 continuous distributions. It measures the maximum vertical distance between the 2 cumulative distribution functions.
A small p-value, below 0.05, means the distributions are significantly different.
For categorical features, use the chi-squared test instead. Both are one-liners in scipy. You compare your training distribution to a recent live window.
The key is to run these checks automatically on a schedule, not by hand when something breaks.
The full drift check in under 30 lines. Load your training data. That's your reference distribution. Pull a recent window of live inference data, last 7 days, last 1,000 requests. For each numeric feature, compute PSI, run the KS test. For each categorical feature, run chi-squared.
Log the results. Alert if any metric crosses its threshold.
That's a complete, automated drift monitor with nothing but pandas and scipy.
Drift detected. Now what?
First, confirm it's real. Rule out data pipeline bugs, logging errors, or feature engineering changes. If the drift is real but mild, recalibrate. Adjust decision thresholds, not the model itself.
If the drift is significant, retrain. Collect recent labeled data that reflects the new distribution.
For concept drift, retraining is almost always the only correct fix.
Build retraining into your pipeline so it's a button press, not a 3-day project. The goal is a loop: deploy, monitor, detect drift, retrain, redeploy automatically. Common monitoring mistakes: only checking accuracy, which you can't do without labels, and which arrives too late. Monitoring only in the first week and then forgetting about it. Treating all drift equally. Mild shift and severe shift need very different responses.
No alerting pipeline, a PSI report nobody reads, is the same as no monitoring.
Using the whole training set as the reference instead of a clean, representative subset.
If this helped, subscribe. Explainable ML is next. Quick recap.
Models decay because the world changes while they stay frozen.
Data drift. Input distributions shift. Concept drift. The correct answer changes.
PSI measures input drift. KS test and chi-squared confirm it statistically.
Monitor prediction distributions even when you have no labels. It's free and early. When drift is confirmed, recalibrate for mild, retrain for severe, always automate the loop. Episode 33, Explainable Machine Learning, SHAP, and Lime. Your model is live and monitored, but why did it make that specific prediction?
SHAP values, Lime, and why explainability matters for high-stakes decisions.
Subscribe so you do not miss it. Challenge task: build a drift detection script for any deployed model. Compare training distribution to 100 simulated live samples using PSI.
Run a KS test and print a clear drift verdict for each feature. Solution in the repo.
Post your output, even a screenshot of the terminal, in the comments.
Deployment is not the finish line.
A model without monitoring is a model you're not responsible for anymore.
Watch the inputs. Watch the outputs. React when they drift.
That's what separates a production system from a weekend demo. Episode 33, Explainable ML with SHAP and Lime, drops next. Subscribe.
Have you caught silent model decay in production? Tell me in the comments. See you in the next one.